I'm going to be talking about something that is pretty simple for an offensive security mindset, and that's the tool Responder. And I'm going to be talking about it in a different way. I'm not going to talk about how to use Responder, although I'll show a point of concept or a way in which it is used. But I'm going to be talking about how to defend against Responder. So this video and the GitHub repo that I'll link to is called Responding to Responder. So what can we do from a defensive mindset to defend against what Responder is doing? Defensive insights within a compressed format. So a little bit about Responder. So on Hack the Box, they've got a box that's worth having a look at. This is where I first interacted with Responder and understood that, hey, there's some just innate vulnerabilities in the system that need to be addressed. So Hack the Box has this box, Responder. It's part of their starting point series, and you essentially have to go through a system and you use Responder to listen in and take the password hash to then give you access to that machine. So go and check that out. It's part of their free series as well. The starting point, you just sign up to Hack the Box Labs. This is not endorsed or paid by them. This is totally just me telling you that it's there. But that's Responder. So I'll cut back to me for a moment as I set up a machine to just show you exactly what I'm talking about here if you haven't heard of Responder or you don't know what I'm talking about yet. So here you can see I've got ParrotOS in a VM running on the left, and then I've just got Windows Explorer on the right on the local machine that is connected to the same network. So what Responder does before I run it is it exploits a built-in protocol that Windows will use that it defaults to, or multiple protocols that it will default to when DNS fails it. So some of them you may have heard of, some of you might not have heard of. These are NetBIOS, LLMNR, as well as your mDNS. Now, these are all discovery protocols. So the idea is that the system or the computer will ask, hey, I need this resource, whatever it be. And it will first ask DNS. And if DNS fails it, it's going to ask its local host file. And if it isn't there, it's then going to broadcast essentially to the local network. Does anyone else know where this is? And that's where Responder comes in and goes, I know where it is. And then it pretends to be anything that you're trying to get, obviously within reason for what is supported. And then it asks you authenticate to it, and it takes that hash. The other thing it can also do is around WPAD. So that's the web proxy auto discovery protocol. So this works when a browser gets set up and it wants to ask, hey, is there any sort of proxy that I need to use? And it auto discovers that file. So Responder can use that to become a rogue handout to then ask for credentials and same sort of thing. So what we're going to do is we're going to pretend to just do a file share server, and we're going to use Responder to get in the middle of it. So in the VM, I'm going to run Responder. And I'm going to say that the interface is ETH0, and I can put some other flags after, but in this case, I'm just going to go with defaults. Now I'm going to go back over to my Windows machine, and I'm going to try and connect to file server that doesn't exist. And you can see straight away that Responder has injected a request for username and password. So I'm just going to say, I am the user, and the password is just going to be password. Boom. And you can see straight away, so on the right-hand side, all that the user or the victim sees is access is denied. But on the left-hand side, we have gone ahead and captured what we need. So that's the hash there. We could save that into a file and use something like John the Ripper to crack that hash. And then once we've done that, we can sort of do a million different things because we have the credentials. I think the issue here, however, isn't so much as people mistyping a file server or going somewhere else, as much as it is pre-mapped file servers, printers, resources on a corporate device that when on a different network try to reconnect, they're using the cached credentials to authenticate. And so real world, what that looks like is if you have a corporate device that has some file servers that are pre-mapped and that person uses that laptop over in some public Wi-Fi, and there is another person on that same Wi-Fi, that same network that's using Responder, your computer will automatically be asking for these resources and using the cached credentials, which then get captured by Responder, and then that person has what might be your login credentials to your corporate network, to your corporate devices and services. So that's pretty bad. That's not minor. So I think that's where the big issue comes in. And so this got me thinking, what can be done from a defensive point of view? How can we stop Responder? And so I went about researching this and looking into it and trying to find every which way to have a look at this and fix it. How can it be done? And how can it be done via Intune? And there's a lot to be said about people sharing about LLMNR, NetBIOS being blocked, but when it came to mDNS and WPAD, there was sort of a little bit less. So I went ahead and put together everything that I found, and I've put it up on this GitHub repo, and it's called Responding to Responder Guide 0001. And it comes with a guide as well as, you can see there's a bit here, so I'm going to link this in the description. And the guide looks something like this. You can see a nice, beautiful page. But what it's covering is there are 3 main protocols, and then there's also Web Proxy Auto Discovery Protocol. So the 3 main is Link Local Multicast Name Resolution, Multicast Domain Name System, NetBIOS Name and Name Service. So these 3 are the main ones. And like I said before, it'll go through a process where the computer asks the DNS. If it doesn't get anything, and it looks in the local host file, and then it will use these protocols to ask everyone on the network, hey, do you know where this resource is? And in a corporate network, you shouldn't have that. You just shouldn't. You should have DNS, you should have authoritative services that are telling the computers what they need to connect to. Now, cautionary, check your environment, because you may have legacy systems that depend on NetBIOS or something else like mDNS for maybe IoT devices. Just check your environment before you roll these things out, because they might be using something that is legacy and you may need to make adjustments for that. Last is the Web Proxy Auto Discovery Protocol, where your browser is going to reach out and ask, hey, is there a proxy that I need to be using? And auto discover that. That's something that you should really have a look into, because unless you're setting it via DHCP and you have that sort of locked down, you probably don't need it. So these are the 3 main, and then I want to say the extra that's sort of outside of these would be the Web Proxy Auto Discovery Protocol. So in this document, I've gone through what the context, implication, solution, and impact is, as well as the technical control. In this video, I'm just going to talk about the technical control for each of these 4. So under the link local multicast name resolution, there are 2 technical controls that we can employ within Intune. So leveraging Intune, using a configuration policy, we can use the administrator templates, network DNS client, to enable turn off multicast name resolution. This will turn off multicast name resolution. Next, we can also turn off smart multi-home named resolution. So these are the 2 that we can turn on to stop the protocol from working. Now, where the differences come from the other protocols is there isn't a switch that we can just turn on and it works. So it gets a little bit more hairy. So the mDNS, the multicast domain name system, has to use a registry key. And so here I have a raw script that you can put as a platform script that's going to go and look for the path and the D word that's there in the value and test if it's there, if not create it, and if it's there, check that it's got the right value, if not, update it. So this will set the enable mDNS to 0, which essentially will disable it. Then if we go back to our table of contents, NetBIOS name service, the technical control here is also a platform script. So we're checking for NetBIOS options. Now this one was really interesting. There are a lot of different NetBIOS things that you can do within Intune for configuration policies, and it sort of restricts the usage of NetBIOS, but it doesn't stop the exploit from working. Only this does. Now what this correlates to is if we were to open up our network. So we open up network connections, and what we need to do that this registry value is checking is we need to go to properties on each one. We need to go to our IPv4 properties, go to advanced under general, WinS, and here this NetBIOS setting, disable NetBIOS over TCP IP. So this will disable it against the interface completely. So I could not find anything else within Intune that would do this, except having a platform script that will iterate over every single interface and make sure that this is set to, I believe, 2, where it is set to disable. So that's how you disable NetBIOS. So here it is. Then if we go back here, we can have a look at, lastly, our web proxy auto discovery protocol. So the technical control is also a registry value, and that's looking for disable WPAD and setting it to 1. Interestingly, I also heard that if you open up your internet options, go to connections, LAN settings, this toggle here can also help. Now I found that I couldn't get WPAD to work with responder when I set the registry value, but I've also seen in a video that I'll put in the description that this can also correlate to it. So that's the main guts of it, but there is a ton more here to be said. And this is where I go into additional measures, and this is overkill for most environments, but definitely have a look and turn on everything that you need to. So these are, what are we going to do if we assume that the turning it off hasn't worked, or there's a way to get around that? And this is where we have to constrict what measures are available for the threat actor. So the first one is around protocol and name resolution hardening. I'm not going to go through everything, but definitely go have a look at the GitHub repo and the guide, which will provide all of this detail, and you'll see a purpose for every single control. Some of them are going to be NetBIOS. Some are going to be around digitally signing communications. So where we're talking to the server, is it digitally signed from a client and server point of view? Also talking about different types of network discovery protocols that may not be needed in an environment. And that's that. Then the next one that's really good to know is, if we can assume that someone can get our NTLM hash, what can we do to lessen the risk or make it harder for the attacker? So we can do things around configuring SMB v1 client driver, and then we want to disable the driver. So we want to push up our authentication methods as high as possible. So we also want to have a look at Do we want to allow unencrypted password to third-party SMB servers? Well, no. So let's disable that. And then NTLM, if we aren't using it, if possible, can we block it altogether? So this is something to really consider in your environment. Can you do that? Other than that is going to be to restrict NTLM to be V2, so being a higher security, or a newer version rather, as well as disabling your hashing for your LM, your LAN manager, and turning on credential guard. And then lastly, an attack surface reduction rule would be to block credential stealing from Windows local system authority subsystem. So I know I haven't gone over everything in this video, but I wanted this video to be live on the channel so that people have a point of reference when they're looking up, how do I go about responding to responder? How do I help with, NetBIOS and LLMNR and mDNS and blocking those things? What can I do? Well, I've made the GitHub repo. I've showed a little bit about how it works. And what I'm going to do now is I'm going to pause the video and I'll come back having applied some of those changes to this computer. I'm going to try again with responder. Okay, so I've applied the changes. They are equivalent on a local machine. Now, if I run responder again, and let's say we are going to hello world, boom, nothing. Nothing has been picked up by responder and nothing has been connected to, and there's no username password that's being requested from File Explorer on our victim machine. So we can say it worked. So this is sort of the way to defend against responder. And I think it's something that we really need to consider as defenders, because if this is a very easy box on Hack the Box and is free, well, it's probably common knowledge. And if we're not thinking about it from a defensive point of view, we need to, because this is built in. It's not something that is disabled by default. This machine that's running was a Windows 11 machine with all of its security updates. It even has a paid home Defender license on it. None of that changed. That NetBIOS was still relied on, as well as your link local, and your multicast. All of these things were just there. They're innate. So we need to consider these things. And I want to say, as a parting thought, for defenders out there, I think we need to, and I know a lot will say, yeah, we already are, but for those that aren't already, you need to start thinking like an attacker. You need to actually go on Hack the Box, try Hack Me, pen tester labs. You need to go and get the mindset of a pen tester to then defend properly and adequately in your environment. So I hope this has helped. It's been a bit of a different video to what is usually on this channel, but please leave a comment for any insight you might have if it was helpful, but also if you can think of another way that we can defend or block this attack or this exploit in a more robust, easier way, I'd be more than interested to hear. It's been probably a week of me just looking this up and researching and trying to find the best outcome that's going to be the least touch. And this is what I've come to. So let me know if you have any insight into this. But thanks again for watching, and I'll see you in the next one.